All right. So rounding, if you're unsure how to round, there's instructions on the front page. But let's just look at the example. What did you get for the nearest whole number for this first one? 539. The 5, if it's 5 or higher, we look at the number before, the one we want to round. 5 or higher, rounds up. Nearest tens. Yes, this number is a lot closer to 540 than it is to 530. Right? We look at the 8, and the 8 rounds a 3 to a 4. Okay, hundreds. Does the 3 round the 5? 500. It's closer to 500 than it is to 600. Nearest tenth. 0.6. Good. The 9 rounds, the 9 rounds the 5 to a 6. Hundredth, 2 decimal places. Okay, good. So this is where students make a lot of mistakes, is this one example. So when you have a 9, and the number before it, in this case, is a 6, right? It's 5 or higher. It's rounding the 9 to what number? A 10, right? Well, we can't write 10, so that changes the 5 to a 6. You have to write the 0. You have to. Because it wants 2 decimal places. It's rounding it to 60. 59 is being rounded to 60. But you have to write that 0. First decimal place is the same thing as which one? Tenths. And second decimal place is the same thing as hundredths. Okay. I changed, yeah. Okay, this guy, nearest whole number, 10,965. Nearest 10, 10,960. The 4 rounds the 6 to a 6. It doesn't actually change. It doesn't round, right? Nearest 100. Good, 1,100. Or sorry, 11,000. So the 9 is rounded to a 10. So that's how we get. Nearest 1 decimal place. 10,964.9. 10,964 point. For 2 decimal places? Is it 90? Remember before the 9. Does a 3 round the? Remember when we're rounding to 2 decimal places? So if I'm looking at hundredths, I have to look at the number after. Right? I want 2 decimal places. I look at the 3rd decimal place. If it's 5 or higher, that next number, that rounds. Because this is a 3, is that closer to, like if we just think of the number, if it was 89.3, is that closer to 90 or 89? 89, right? So when it's less than, if it's 4 or less, this would actually be, oh yeah, here we are, 89. And then first decimal place is the same thing as that guy. 2 decimal place, same as that guy. Right, same thing. Okay, using a graphing calculator for rounding. We're skipping that. Big line through it. Don't need to know. Okay, good. If you like that, then you can put a line through this whole page. We're skipping all that. Yeah, the whole page. Then we turn the page there. And we're going to put a line through this whole page. See, we're getting through lesson 1 really well. And we're not putting a line here. I know. It felt good, didn't it? Okay, so the first one, using a graphing calculator. Find the value of 2a plus 4b minus a squared plus b squared when a is equal to -2 and b is equal to -3. Okay, so when you substitute for a variable, you want to use brackets. I'm going to show you 2 ways. One, the way you've taught before, so using brackets. So when we see A, I'm going to put whatever A is in brackets. 2 times, what is A? Negative 2. So 2 times negative 2 plus 4. And I'm replacing B, so what do I need? Brackets. And B is negative 3 minus, what do I need for A? So before I type or write bracket, negative 2 squared plus bracket, negative 3 squared. So whenever we substitute, whatever we're subbing in, you have to put in brackets. So let's type that in our calculators. Uh-oh. Let's see how much patience I have today. That's not good. There we go. Okay. So, you got negative 11? Okay, I'm going to show you something else. You're going to love it. Only works though if you have a graphing calculator. So if you have scientific, does not work. Okay, so every time you sub, you have to put those brackets in. Just like that. Some of you, there's a square button, right? Instead of going to the power of 2, you can just push the x squared button. And it looks better. Negative 11. Good. Okay, so here I'm going to show you how to use your calculator to also sub a different way. So we can actually store letters as numbers. Oh, how do we do that? Well, if you look at your calculator, there's a store button. It actually says STO. And it's right above the on button. Do you see that button? Yeah. So first you have to type in the number you want to store. So let's start with A. A is equal to negative 2. So I want you to write negative 2. And then we're going to actually, sorry, we have negative 2, push the store button, STO. Now I want to store it as A. Now some of you might have already learned how to get letters and to type. Oh, look, you can type notes to each other already. Alpha A. So alpha is right above the math. So alpha math is really what you're pushing, right? Because it's alpha, the A button. So alpha A. And push enter. Now every time you write A, alpha A, that's equivalent to negative 2. Okay, so we pushed alpha, and then we found A. Okay, now we also want to store B, right? So what would I type first? Negative 3, store alpha B. And where is B? X. Beside A, logically, yes. It's not like a regular keyboard. It's in alphabetical order. So alpha B, enter. You have to push enter. I should write that in. So now we can write this expression that we see above, and we don't have to worry about brackets. I'm going to type it in exactly like I see it. 2 alpha A, oops, so 2A plus 4, then what? Alpha B minus alpha A squared plus alpha B squared. Negative 11. Isn't that nice? That's nice. That really comes in handy in physics. Especially if you end up taking physics 20. It will come in handy, let me tell you. Yes. How do you clear your letters? You just reset your calculator or store it as something else. So if I wanted to change A, I just could change it to negative 3. Alpha store, store alpha A. So now A is negative 3. Just store it as something else. Or you can reset your calculator, and that will reset it all. Yeah. Okay, cool? All right, moving on. Isolating a formula is going to be very important in this unit. So, for example, in this guy, if we want to sub in v equals 12, right? We are essentially looking for t. So you have to be able to, in science, they make you rearrange the formula first and then sub everything in. Yeah. Yes. In math, you're lucky. We say sub first, then use algebra and rearrange. But actually makes it a lot easier because you get 60 equals, what's v? 12 times t. And so it's very easy to see what we need to do. What do we need to do to isolate t? Divide by 12. Okay, do you know what 60 divided by 12 is? Good. Okay. So here's a good one. They said S is equal to 100. And the formula we have is S is equal to 4 pi r. A formula you're going to actually learn about this unit. Okay. So it stands for surface area for something. Specifically a sphere. Oh no, that's different. No, that's different. 4 pi r squared, I believe it is. Close. Okay, so let's sub in S. S is 100. So I'm going to replace the S with 100. So we have 100 equals 4 pi r. I want to isolate the r. So how am I going to isolate the r? Yeah, we could do divide by 4 and then divide by pi, or we can do it all at once. Divide both sides by 4 pi. What you need to be very careful of is your calculator does BEDMAS. And so if I type in my calculator 400 divided by 4 pi, what is it actually doing? It's doing divide by 4 and then multiplying by pi. It's not dividing by 4 and pi. So what do you need if there's more than one thing on your denominator? Brackets, those invisi brackets. So if I were to type this in, 100 divided by, you'd have to put, if there's more than one thing on your denominator, you always wrap it in brackets. 4 pi. Okay? And so to the nearest tenth, what would that be to the nearest tenth? So if we have 7.95, I want one decimal place. That means I look at the second decimal place. It is a 5, so does that round that 9 to a 10? So it becomes 8.0. You have to have the 0 if we want one decimal place. Okay? All right, let's do this last one because it's good practice for this unit. 95 is equal to 4/3. This is a fun one. Pi r cubed. There's a few ways we can isolate this one. What would you do? Divide by what? Close. Okay, so we first have to isolate r cubed. You can't isolate r before you isolate r cubed. So we're going to divide by 4/3 pi. What will I need on my denominator? Brackets. Okay, because there's more than one thing, so we're going to be typing in 95 divided by brackets, 4/3 and pi. Pi is the second hat. Okay, we do not use 3.14 anymore, ever. We use the more precise, exact, symbol on your calculator. Okay, so 4/3 pi should look like that. Did you get 22.679? So 22.679 ... is equal to r cubed, and then we cube root both sides. Now, do you remember how to cube root something? Math, number 4. Now, instead of typing that whole thing out, answer. Do you know where answer is? where the negative sign is. Do you see that little blue writing above the negative sign? So if we push second negative, that will put in your previous answer, the cubic root of the previous answer, because in this unit, we only want to be rounding the final answer. We want to use exact numbers all the way through, all those decimal places. And so using the answer but key helps us do that. Okay, science will do the same thing. We don't want error in our work. So it's the nearest tenth, it'd be 2.8. Okay? Alrighty. So we're going to skip this one. How did we get this one? We cube rooted it. How do we get, oh, answers? Answer is, to get answer, you push second and then the negative button. Why am I cube rooting it? Because it's r cubed. So the opposite of something to power 3 is the cube root. Just like the opposite of squaring something is a square root. Yeah, to isolate the variable. So when you take the cube root of r cubed, that's just equal to r. Right? They cancel each other out. Okay. All right. So moving on. So that's lesson. That's that one. Okay. Move on to lesson 2. Let's see how fast I can move. All right. There's a lot of words here, so we're gonna kind of highlight what's key here. Before measuring tools were created, guess what? There wasn't always a ruler or a meter stick. People often use common objects as an aid, which makes sense, right? If there wasn't a standard system, what do you do to measure? Well, everybody has a foot. But what's the problem with that? Everyone's feet are different sizes. In fact, it used to be, I think it was in England, that whoever was in power, whoever's the king, their foot size was the new foot. So it changed depending on who was the king. And then if there's a queen, well, they have small feet. So that's pretty funny. So it's called a referent. A referent is objects we use to describe or use as a reference for measurement. So a referent is a reference for a measurement. You've learned about reference before. Okay? Pinky, what is that approximately? A centimeter. The width of your nail. A millimeter. Does anyone remember what else is there? Meter is? A deca? Or 1 decimeter? Just think the hand span. Hand span is 10 centimeters. Like this. Yeah, I think that's a decimeter, so 10 centimeters. Pretty sure. Does it say in here? Okay, one pace, one step. Well, I have small little legs, but is approximately a meter. They do the same thing for a yard. Because you'll notice a yard is actually really close to a meter. I'll talk about how close. They're not the same, but they're close. Your thumb width? Is that a centimeter? I thought it was our pinky. Anyways. Okay. So reference. You've learned about reference. We'll learn about reference for imperial units as well. This unit. So you've learned the metric ones in elementary, and then you have to wait till grade 10 to learn about. It's funny. 1 hand is 4 inches. Is one of the references. Which is remember I told you 4 inches is approximately 10 centimeters? So, yeah, a decimeter. So here's some interesting reading if you want to read where it came from. Anything interesting here? A chain is the length of a cricket pitch. Cricket's not very popular these days in Canada. 10 chains is a furlong. I bet you never heard of a furlong. Yeah. Okay. So it says looking at these reference above, the pace, I guess this is called the cubit, or cubit. is this part here. Okay, your span, your hand width, or your thumb. Using those, which one would you use to measure, approximate the length of a football field? Pace would be appropriate. The length of a compact flash drive. What? Flash card? Compact flash card? Like a US, are they talking about a USB? It's also called a thumb drive, so wouldn't that be a good referent? The thumb. The height of a horse. A cubit, or you could also use your span. So cubit or span, I would take. Yes. So it'll probably be like a multiple choice question, and it'll be like, which one best, which referent best, you know, like those things, and then you'll have A, B, C, D, and there will be an option, like an obvious answer, as long as you know what each one like is for. Okay, so the imperial system, really quickly, is in the U.S. So the imperial system versus is from English, the British, right? And then the metric is from the French. The French. Back in the day, the French and the English didn't get along so well. They had their own systems, right? So the French is actually with the metric, where the metric system came. The British and the English is where the imperial system came. Hence the imperial, like, I don't know. So today it's used in the States. You need to, well, you don't need to know these, but you do. These are on your formula sheet. It's very handy, especially the first two. You should probably know that 1 foot is 12 inches. Okay? Probably should know that. 1 yard is 3 feet. You should probably know that, like in real life. Like that's something you should know. Yeah, it should be common knowledge. It should be. Doesn't mean it is. That one I'm not as picky on. But it's good. It's good to know. 1,760 yards is 1 mile. Okay, we know the SI, or the metric system, right? The conversions, we're going to review that. You've done conversions for the metric system, like in elementary. We'll review that today. Okay, moving on. What reference do you need to know? So much writing, so I'm just going to highlight what you need to know. Okay, the width of your thumb is approximately, so when they say the width of your thumb across the joint, we're talking about, if I draw a thumb here, oops, not a very good thumb drawer, as you can see. Okay, so this is the knuckle here. Maybe it should be a little fatter. Let's try a little better. Something like that. The thumb fat. Okay, that is approximately 1 inch. Now, for some of you, if you have bigger hands, it could literally be the width of your thumb. I do not have that's long. Okay, so about, oh, you know what? Would you like a ruler? Yeah. Would you like a ruler? These reference you should probably know, but they're like the width of a fingernail is a centimeter. The what? The width of 5 toes of an adult is about a decimeter. Go ahead. But leave your shoes on.
How are you? You're not gonna
No, there's no air fresheners, and there's not great circulation. The thickness of a dime is about 1 millimeter, right? We also say the thickness of your nail. It's probably a little bit more than your nail. You need, well, but logically, right? You should probably logically be able to figure that out, right? Some of these are, you don't have to memorize all of these, no. Okay.
Why do you have to specify in North America?
Where?
The average height of a 4-year-old is more than there.
Oh, that makes a difference, right? What country you're in?
Yes.
The average height, yeah. Okay, so let's do number 3 really quickly. Consider the task. You are granted the task of estimating the length of a standard letter size paper. Okay, listen up. What referent could be used to measure the length? In SI. So first of all, SI, is that metric or imperial? Metric. Okay, metric. So give me an example of metric units. Centimeters. In fact, millimeters, meters. Which metric unit, guys? Which metric unit would you use to actually measure the length of a piece of paper, a standard piece of paper? This paper right here. Centimeters. Good. Oh, I just gave myself a sliver. Oh. Yeah, for my meter stick. And this. Okay. I know what a sliver is. Okay, so what referent estimates a centimeter? Which referent is a centimeter?
I don't understand.
Okay, so what piece of your body would you use to estimate how many centimeters is this piece of paper? Okay, the width of your, sure, pinky, or you can say nail. A nail. A fingernail, the width, right? Depending on which one's closer. The width of your pinky. I like pinky better. I also like writing pinky. So you could actually take your piece of paper, line up your pinkies, and start counting. 1, 2. Have you done that before in elementary? Okay. Okay. Here we go. Can I get your attention? Rulers, please, down. Or, yeah, rulers. Identify a referent which could be used to measure the length in imperial. So imperial, what unit would you use? Imperial. Inches. So which referent, the how would he call that? The width of a thumb across the joint. That's how they word it. The width of the thumb. I can't spell thumb. Try this again. I can. I just across the joint. Okay. Now we know that it should be 11, right? 8.5 by 11. That's what paper standard size is. 11 inches is your length of your paper. If you want to check, you can count how many thumb widths, like this, across. Okay. Let's move on though, because we really need to get going. Explain the process of measuring the length in imperial. Let's just skip this. Move on. I think we're gonna skip all of these. All right. We do not need to go through lesson 3, so if you would like to, you can cross out all of lesson 3. Every single page. It is helpful to me when you cross it out, because when I'm flipping through, all of lesson 3, not the assignment for lesson 2. Don't cross out the assignment for lesson 2. Assignment for lesson 3 you can cross out. For lesson 3, yeah. You can cross out the assignment for lesson 3. Yeah. Not lesson 2, though. You'll have homework for lesson 2. Okay. quickly, so here's an example of something you might see on a test. Okay, you don't have to write this down, just listen. It says, which reference could be used for 1 inch? The distance from where you are to the nearest restaurant, the diameter of a bicycle wheel, the length of your calculator, or the width of your largest toe. Right, so that's an example of how the test question would be. Okay? Yes. Now, I might have thrown in instead the width of your largest toe and then maybe the width of your smallest toe. It's probably the largest toe, right, if I wanted to throw a distractor in. Now, we're also going to talk about conversions from the metric conversions. On your formula sheet, which you all should have, what is wrong here? Okay. Your conversions are on your formula sheet, right? You don't have to memorize the metric. I believe the metric chart is on there. Yes, it says kilo. You have KH, DA, yeah, this is what you have. And then there's your actual units. And then deca, right? Deci, I mean, centi. On your formula sheet. Milli. That's what's on yours. And then this is your units. So, like if you had meters, decimeters, isn't it? You don't write D yet. You just it's just D, D, just D. Just D. I don't know why I wrote it out. D, centi, milli. So meter, meter, meter. Okay. So you might have found a way to memorize this in the past, right? King Henry's daughter Mary died chasing men. I have. Okay, well, what's yours? Oh, King Henry drank my, for meters, dark chocolate milk. I've also heard kill him dead, but stands for the base unit, but don't commit murder. Kill him dead, but stands for base unit, don't commit murder. Okay? King Henry does it usually for units. Oh. Usually drink chocolate milk. Okay.
And the other one is kind of
dark.
Yeah. She doesn't usually do cooking much. What?
I won't repeat that on the microphone. Okay. So essentially, is a meter larger than a millimeter? Is a meter larger than a millimeter? Yeah. Yes, right? So there's going to be more millimeters in 1 meter, right? So when we move this direction for each, essentially we're moving our decimal place. So if I'm moving my decimal place to the left, am I dividing by 10 or multiplying by 10? If I'm moving my decimal place to the left, so if I move this over to become 0.1 instead of 1, did I divide by 10 or multiply by 10? You're dividing. Okay, when we move to the left, we divide by 10 for each spot. When we move to the right, we multiply 10 for each spot. Okay? So we're going to do some conversions. So for example, I have an example up here. It's not in your book. 32,000 centimeters. Nope. No, that's right. Because you're going to have more of the smaller unit to equal 1 big unit, right? So here we have 3,200. So if we think about what I like to do, is if you have 3,200 centimeters and I'm going to kilometers, you can think about how many hops you're taking. Do you ever do that way? How many decimal places? So if I'm at centimeters and I'm moving to kilometers, I want to move 1, 2, 3, 4, 5 decimal places to the left. So my decimal place is after the 0, and I am going to literally make 5 hops to the left. So let's make this thinner. 1, 2, 3, 4, 5. So we end up at 0.32 kilometers. That's simple. No. Let me see. Centimeters? No, like centimeters, yeah. Then you would write, then it'd be 32. Yeah. Okay, so for example, hectometers to centimeters, I want to go, let's use purple, 1, 2, 3, 4 places to the right. Right? How many jumps to get over? 4 jumps. So we take our decimal place and I want to move 4 to the right. What happens when there's no number there? They add 0. So 1, 2, 3, 4 gives you 2,500 or 2,500. Pretty simple? Okay. So your workbook, I'm not going to go through all of these. Let's look at the next page. Oh, shoot. Number 1. Let's not do number 1. Let's go to number 2. Convert 7.5 meters to centimeters. Okay, can you guys try this? Okay, so if you have to write King Henry's daughter Mary died chasing men. Or whatever you use. Whatever you use. Okay, meters to centimeters. You will always have your formula sheet. So from every unit exam, your midterm exam, and your final exam, you will have this formula sheet. Okay? You're welcome. So, how many places are we moving? From meters to centimeters. 2 to the right. So we want to take our decimal place, move it 2 to the right, which gives you 750 centimeters. Or you can think of it this way. If it's 2 to the right, we're multiplying by 10 twice. Or multiplying by 10 squared. Right? 10 times 10 is 10 squared. So if you multiply by 10 squared or multiply by 100, it's another way to get it. Okay? I find moving the decimal place a lot easier. Metric is, base 10 is so lovely. It makes sense. Base, like, there's no consistency with the imperial. Right? Just annoying. Okay, milligrams. So instead of m's, what are we going to have? All my m's will turn into g's. Right? That's all you have to do. Our base unit is now g. So we want to go milligrams to kilograms. That's a lot of jumps. How many? 1, 2, 3, 4, 5, 6 to the left. To the left, to the left. So yeah, I can't speak. You should be used to this already. I'm a mumbler. 1, 2, 3, 4, 5. Guess what we have to introduce? A 0. So you do not write decimal 0.72350. What would I write that? 0 decimal. You need the 0 in front. That's a big pet peeve of mine. Okay? Okay? Alright. Alright, we're going to skip C. So if you look at the chart that's on the previous page, just so you know, okay, there's some other ones you might have heard of and that you've used in science. So a micrometer doesn't go right after a millimeter, okay? So it's basically 3 places over from the millimeter. So it's 10 to the power of -6. So you're like from the distance from a meter to a micrometer is you'd have to divide by 10 6 times. Okay? And then a nano, you'd have to divide by 10 9 times. Okay? You'll use those in science, right? There's 1,000 micrometers. in 1 millimeter. And 1,000,000 nanometers in 1 millimeter. Yay! Okay, so we're going to skip over to example 3, is where you were actually, really quickly. Can you try 12A? Kilometers to millimeters really quickly? Oh, it says in scientific notation. We can skip that. Just convert it. You don't have to worry about scientific notation in math. Okay, be six spots, right? 6 jumps to the right. So you're gonna add 6 zeros. Okay. All right, we need to get moving. So move. Let's look at the next page and look at number 4. So most of the stuff today is all review, right? Other than reference for imperial. When we do conversions, there's multiple ways we can do conversions. One is, we're going to actually mostly do it, and we'll do conversions tomorrow, and it's mostly we're going to use the same method you use in science, okay? And so that you're consistent across all your classes. You can use proportional reasoning, where you have a fraction equals a fraction, okay? And so this example is that Alice, Jim, and Rema were asked to convert 300 centimeters to meters. Part of their work is shown below. Each knew that 1 meter is 1 centimeter. So Alice's work is she knew 1 meter was 100 centimeters. And so she set up a fraction. So that means x is equivalent to 300 centimeters. Notice that the centimeters were both on the denominator, and then meters are both on the numerator. Okay? Meter. So this would be a meter as well. Meters. Okay? So you can cross multiply. So what she did is she multiplied, if I multiply both sides by 3, the top and bottom, what do you get? How many meters? 3 meters. Okay? So that's one method. I don't love that method. We won't really use that. Same idea. So Jim set it up the same way, but instead he multiplied both sides by, he cross multiplied, is what he did. Okay, so 300 times 1 equals 100 times x, and then divide both sides by 100, and you still get 3 meters. Okay. And Rima did the same thing. She just instead did centimeters over meters. So 100 centimeters equals 1 meter. That means 300 centimeters equals x meters. She also cross multiplied. Okay, and then divide by 100, which also gives 3 centimeters. Okay, or meters. Okay, so you can solve that way, but we're not going to really focus that way. We're going to use proportional reasoning. So if you look on the next page, when it comes to centimeters and like metric, we'll just use the way we normally do. We'll move the decimal place. It's the easiest way. Why try and change what we already know how to do to a new method? Okay. So let's try this guy. A photograph of an African elephant has a scale of 1 centimeter, which represents 0.6 meters. Okay. The elephant's trunk in the photograph measures 3.5 centimeters. What is the actual length of the elephant's trunk? So I'm going to show you what we do in science. Okay. So we start with 3.5, and we want to use it's called is unit analysis. We want our units to cancel. Have you taken science 10, some of you?
Yeah.
You've done unit analysis?
Yeah.
Yay! Okay, so if you have, you're in luck. So because we're going to multiply by the ratio we want to convert. Centimeters right now technically is on the Numerator or denominator for 3.5? Numerator, right? You could write that over 1 if you want. So we want centimeters to be on the denominator because we want that to cancel. We want to be left with what unit? Meters. We want to know how many meters the trunk of the, right? The trunk, elephant's trunk is. So now we can fill in the ratio. We know that what? 1 centimeter is 0.6 meters. So notice here how these centimeters are going to cancel out. This is the same thing as 3.5 over 1. So when you have 1 on the numerator, 1 on the denominator, they cancel out. So we can just multiply then. 3.5 times 0.6, what does that equal? .1 meters. Okay, so that's the method we're going to use. So on the next page, example 7, you can cross off all of the rest of that. This is unit analysis. We're just going to do it. We can do that same with, if we wanted to, kilometers or meters. So what I mean by that is we need to figure out, first of all, if I'm looking for meters, meters are going to go where? Top or the bottom of the fraction? The top, and we want kilometers to cancel so that it's going on the bottom. So what is the relationship between kilometers and meters? 1 kilometer is how many meters? Not 100, 1,000. Okay, and you can see that with Henry's daughter, Mary. So here, 1,000 to get to meters. There's 1,000 meters in 1 kilometer. So 1 kilometer, right, 1,000 meters. So that's how we can also get 12,000. Okay. Okay, we'll skip B. And we're going to skip 8 and go down to 9. Okay, so if we're going to convert meters per second to kilometers per minute, yes, you do need to know how to do that, just like in physics. So let's go straight to B. If we want, so we do one conversion at a time. So we're first going to take care of the meters. Okay? So because meters are on the numerator, it's going to go on the denominator in the first fraction. And we want to convert it to kilometers. Right? So what's the relationship between kilometers and meters? 1 kilometer is 1,000 meters. Okay? Then minutes and seconds. So here we have a second on the denominator. So notice it's going to be on the numerator so that it cancels out. And so minute has to go on the denominator. So once things are canceled, what are we going to be left with? Kilometers per minute. So what's the relationship between seconds and minutes? 1 minute is 60 seconds. And so that's what we want to type into our calculator, just like we see it. We're going to type in 50 times 1 divided by 1,000 times 60 over 1. You don't technically have to go divided by 1, but if you want to, you can. Okay? You should get 3. And so that would be 3 kilometers per minute. Okay, we are finally done. It's a long one. So you need to do some circling. Okay? So head to page 118 first. So lesson 1, 118. Okay? So I want you to circle the following. Number 2, and then you go all the way over to number 9. We want to do D, E, F. D, E, F. Okay. Then 11, A, B, C, and D. Okay. Then page 127, so lesson 2. Number 1, all of it. You don't have to do 2. Number 3, it's a matching. And then 5 to 14, you might need a ruler for it. 8, 9, 10, 11, 12, 13, 14. Looks like a lot, but it's just a quick multiple choice there. Okay? And then last, turn to page 146. Okay? So 1A to H. A to H. So A, B, C, D, E, F, G, H. Just, or you can cancel off the other 2, the other 4. And then 2A to F. Okay. There's some additional ones you can do if you want to try. That would be 118.11E and numeric response 14. So this is the minimum amount expected, right? If you have time for more, do more. Minimum homework for this lesson. Sorry we didn't have much time today. We're basically, if you want to just relax for the last bit, you can. Pack up. I'm sorry. Oh, I need your rule.